Hi friends, welcome to our YouTube channel Naraj Academy. The main aim of this lecture is to discuss about the mathematics previous year questions of PSUs in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notification comes on mobile. If any improvements needed in our video lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Please do watch all our videos on the YouTube itself so that our channel can reach to more number of students. I hope you will do it. So let's get started. So now we are going to solve the 71 question. See the question here. Let x be a random variable that follows the binomial distribution with the expectation of x is equal to 7 and the variance of the x is equal to 6. Then what is the probability of the success P? We need to figure out. See in the question they are given x is a random variable. It is going to follow the binomial distribution. And the expectation of the random variable is equal to 7 and the variance of the random variable is equal to 6. So based on this we have to find what is the value of the probability of success P we need to figure out. Out of the four options, option C 1 by 7 is the correct solution of this question. So let's solve this numerical. So we have to solve this question with the help of the binomial distribution. So binomial distribution formula is the probability of the number of events, or we can say the number of times the success is going to happen is equal to the probability of R is equal to NCR into P to the power of R into 1 minus P to the power of N minus R. So this is the basic formula of a binomial distribution, where N is called as the number of trials and R is called as the number of times this event is happening, or simply we can say that number of times this event has been successful or happening, and P is called as the probability of this event happen. Means for this event to happen, this is called as the probability of that event, and 1 minus P means nothing but it is a probability of failure. So therefore for this binomial distribution, the expectation of the random variable is equal to n into p, where the variance of the random variable in the binomial distribution is np into 1 minus p. Whereas in the question they are given that expectation of the x is equal to 7 and the variance of the x is equal to 6. So based on this we have to find what is the value of the probability of the success P we need to figure out. As I have already told you, expectation of x is equal to n into p, whereas the variance of the x is equal to np into 1 minus p. So therefore as expectation of x is equal to n into p, they already given its value is equal to 7. So this is the equation 1, and the variance of x is nothing but np into 1 minus p. They already given the value is equal to 6. So this is the equation 2. So from these equations 1 and 2 we have to solve, and we have to get the value of the P. P is called as the probability of the success. So this is the basic formula of a binomial distribution, which is the probability of the number of times this event is happening is equal to NCR into P to the power of R into 1 minus P to the power of N minus R. So here N indicates the number of times the number of trials, and R indicates the number of times this event is happening, and P is called as the probability of the success of the event, whereas 1 minus P is called as the probability of the failure of the event. So these are the things that you always have to remember, and expectation of x is equal to np and the variance of x is equal to np into 1 minus p. So now we will solve this one to get the solution. So as I already told you, the expectation of the random variable is equal to 7 and the variance of the random variable is equal to 6. But I have already told you the expectation is equal to np and the variance is equal to np into 1 minus p. So now I will do the division of the equation 2 by equation 1. Then I am going to get, which is np into 1 minus p by np is equal to 6 by 7. So np cancels because it's a common part. So then we are going to get 1 minus p is equal to 6 by 7. I take the 6 by 7 to the LHS and I will take the p to the RHS. We are going to get p is equal to 1 minus 6 by 7. It is equal to 1 by 7. So therefore we can say P is equal to 1 by 7 is the correct solution of this question. So therefore the probability of the success of the event is equal to 1 by 7 is the correct solution of this question. See, I have already told you binomial distribution is going to get applied only when the number of trials is finite and the probability of the success is finite. If these are the two conditions, then only we can say we have to apply the binomial distribution. So binomial distribution is applied only when the number of trials is finite value and the probability of the success of the event should be finite. Then only we have to apply the binomial distribution. Suppose, let me give you some more important details regarding the binomial distribution. Suppose in a question, if the number of trials are infinite, suppose if the number of trials are infinite values, then in the question they are given that the probability of the success of the event is very small value, then you can't solve that question with the help of the binomial distribution, because the binomial distribution will give you very complex result. It will take lot of time to solve that question. So therefore now we are going to approximate the binomial distribution is now approximated to the Poisson distribution, where average value is equal to n into p, where n is called as the number of trials and p is called as the success of that event. So therefore remember one thing, whenever the number of trials are tending to infinity and the probability of success is very small, then you can't solve that question with the help of binomial distribution, because it takes lot of amount of time to solve that question. So therefore we prefer, or we approximate the binomial distribution into Poisson distribution, where the lambda is called as the average value, which is equal to number of trials into the probability of success, which is n into p, where you can go for n very finite value, very infinite value, and the probability of success can be very small. Then you can solve that questions with the help of PD, means Poisson distribution, but not by the binomial distribution. Suppose another case, suppose if the number of trials are infinite, but the probability of success is a finite value, it is not a small, it has some small amount of finite value, then still you can't solve that question with the help of binomial distribution, because it is going to give you lot of amount of time to get the result. So therefore we are going to approximate the binomial distribution into a normal distribution. So therefore these are the two things that you always have to remember. See, whenever the number of trials are infinite and the probability of success is very small, then we are going to approximate the binomial distribution into the Poisson distribution. Similarly, if the number of trials are infinite and the probability of success is a very finite value, still also we are going to approximate binomial distribution into a. So whenever the value n tends to infinity and p is equal to finite value, we are going to approximate the binomial distribution into a normal distribution. So these are the important points that you always have to remember. So now I will take this opportunity to discuss some more important points regarding the different types of distributions that are present in the probability. So which is geometric distribution. Geometric distribution, the probability of the probability of the number of times, the probability of x is equal to r is equal to 1 minus p over to the power of r minus 1 into p. So here we have to suppose there is a dice. Suppose now I need to roll the dice until I get the success. So after the success, I don't have to do the other time of doing that event. So therefore we can say we have to go for the process until we get the success. After that we have to stop that process. So therefore simply we can say that if r, suppose there are total r number of times you are going to do the event, sort of that definitely r minus 1 number of times we are going to get the failure, and only one time we are going to get the success. So the probability of failure is equal to, which is 1 minus p for number of times, which is r minus 1. Similarly here the probability of success is p, but it is going to occur only for the one time. So therefore this is we call as the geometric distribution. So probability of x is equal to r is equal to 1 minus p over to the power of r minus 1 into p, where 1 minus p is called as the number of times, or we can say the failure of the event which is occurring for r minus 1 number of times, and p is called the probability of success which is occurring only for the one time, because after that the process is stopped. So this is the case, then the exponential of the random variable is equal to 1 by p, and the variance of the random variable is equal to 1 minus p by p square. So these are the important formulas that you always have to remember for the geometric distribution. So for geometric distribution, the exponential of the random variable is equal to 1 by p, and the variance of the random variable is equal to 1 minus p by p square. So now we will discuss about the Poisson distribution. As I already told you, whenever the number of trials is very large and the probability of success is very small, then we go for they've already told you that then that is the condition, then the binomial distribution is approximated to the Poisson distribution. So here this is called as the Poisson distribution, where the probability of the random variable is equal to e to the power of minus lambda into lambda to the power of x by x factorial, where x is called as a random variable and the range of x is from 0, 1 to up to infinity. You can take any value. So then lambda is equal to alpha into delta t is equal to n into p. As I have already told you, lambda is called as the average number of occurrence of event in a unit time, where lambda into delta t is called as the average number of occurrence of event in delta time duration, or it is also called as the mean, and we can say the average value is always positive, which is greater than 0, and it is equal to n into p, where n is called as the number of trials and p is called as the probability of success. As I have already told you, the n value should be always very large value, means nearly infinite, and the p value should be always very small. So n value, whenever they are given very large value, and p value whenever it is given small value, then we prefer to use the Poisson distribution but not the binomial distribution. So therefore we can say that lambda is equal to alpha into delta t is equal to n into p, where lambda is called as the average number of occurrence of event in a unit time. Means suppose in a given unit time, how much number of times the event is becoming success, it is called as the alpha. So average number of occurrence of event in a unit time. Similarly, if you want to know the value of lambda, which is average number of occurrence of event in delta to duration, or it is also called as a mean, and the average value is always positive, which is greater than 0. So average value, or we can say this mean value, is always greater than 0. So lambda means, this alpha means the average number of occurrence of event in a unit time, whereas lambda indicates the average number of occurrence of event in a delta t duration, or it is also called as the mean, or the average value is always positive, which is greater than 0. So now here, see, as the random variable x is changing from 0 to infinity, so therefore if you do the summation of each and everything, which is probability of x is equal to 0 plus probability of x is equal to 1, up to how many number of random variables are there, up to infinity is equal to, their all summation should be always equal to 1. Suppose the first movement, if they ask you about the first movement in the Poisson distribution, it is equal to lambda, and the second movement is equal to lambda plus lambda square. So first movement means lambda, second movement means lambda plus lambda square. So therefore now in the Poisson distribution, always the mean value is equal to variance value, which is equal to average value. So therefore mean is nothing but mean is equal to average value, and the variance is also same. So in the Poisson distribution, the mean value is always equal to variance value. So mean is nothing but expectation of x, and the variance is nothing but variance of x. They both should be always equal. I have already told you expectation or mean are both same. Here mean is equal to, or average value is equal to lambda. So therefore it is always equal to lambda. In the Poisson distribution, always the mean value is always equal to variance value, or the expectation value is always equal to the variance value, but the expectation is nothing but it is equal to lambda value. So therefore these are the important conditions that you always have to remember in the Poisson distribution. So now we will discuss the uniform distribution. Uniform means its value is always constant for a given amount of range. Suppose the f of x is nothing but it is having from a to b, its value is 1 by b minus a, because for the probability density function the area should be always equal to 1. So therefore the area of this rectangle is nothing but this is b minus a, and this is 1 by b minus a. The area is equal to 1 because the product of length and width is equal to 1. So always the area under the probability density function should be always equal to 1, because here f of x is called as the probability density function. So it is having for a to b, its value is uniform or constant, so it is called as a uniform distribution. So therefore by seeing this graph we can say that the function f of x is equal to 1 by b minus a for a to b, and for remaining all ranges it is equal to 0. So therefore f of x is equal to 1 by b minus a for a to b, and it is equal to 0 for the remaining range or otherwise. If this is the case, then what is the expectation of random variable? Then for the uniform distribution, the expectation of the random variable is equal to a plus b by 2, whereas the variance of the random variable is equal to b minus a whole square by 12. So these are the important points that you always have to remember in the uniform distribution. So therefore always the expectation of the random variable is equal to a plus b by 2, whereas the variance of the random variable is equal to b minus a whole square by 12. So with this, because because most of the questions have been asked on these concepts, so I am doing a small amount of revision of these concepts, so that it will helpful for you in the coming examinations. So now we are going to discuss about the univariate exponential distribution. So therefore, whenever the f of x having this type of graph, which is for x less than 0 its value is equal to 0, and for x greater than 0 it is decaying in the terms of the exponential. It is decaying in the terms of exponential. So at x is equal to 0 we are going to get here lambda, so this is called as a lambda. So at x is equal to 0 we are going to get a value of lambda. So for x less than 0 its value is equal to 0, and for x greater than 0 it is having a decreasing exponential. So I already told you area under the probability density function should be always equal to 1. So now we are going to define this function f of x. F of x is equal to, for x greater than 0 this graph is going to follow this curve, which is lambda into e to the power of minus lambda x. If you substitute x is equal to 0 we are going to get lambda. So for x is equal to 0 its value is equal to lambda, and for remaining other ranges its value is equal to 0. So then this is the condition, then the expression of the random variable in this univariate exponential distribution, which is 1 by lambda, whereas the variance of the random variable is equal to 1 by lambda square, where lambda is called as a parameter in this case. So these are the important points that you always have to remember whenever they ask question regarding the univariate exponential distribution, because univariate means only for one range it is present and it is following an exponential distribution curve. So the important points that you always have to remember in this univariate exponential distribution. So now we will discuss about the normal distribution. So for this normal distribution we are going to get graph in this manner. So you can see clearly at mu x value it is going to have a peak value. It is defined for each and every range of the value of the x. So the graph is going to follow in this fashion, which is f of x is equal to 1 by under root over 2 pi into sigma x into e to the power of minus of x minus mu x by under root over 2 into sigma x whole square. This function is defined from x range from minus infinity to plus infinity. So therefore, if this is the case, then we can say that the expression of the random variable is equal to mu x, and similarly the variance of the random variable is equal to sigma x square, because sigma x is called as the standard deviation and sigma x square is called as that variance. So these are the important points that you always have to remember in the normal distribution, which is f of x is equal to 1 by under root over 2 pi into sigma x into e to the power of minus of x minus mu x by under root over 2 into sigma x whole square. So you can see clearly if this is the value of the mu x and this is having a range of sigma x. So this is mu x plus sigma x, this is mu x plus 2x, this is mu x minus sigma x, and this is mu x minus 2 sigma x. So this graph is always symmetric with respect to mu x. Mu x is called as the mean value. So therefore, this graph is always symmetric with respect to mu x. So these are the important points that you always have to remember. So I have discussed all the different types of probability distributions and their expectation value and their variance value. So therefore, in the coming examinations, they may ask any question from these concepts also. So now we are going to solve the 72nd question. See the question here. Sum of mean and variance of a Poisson distribution is 8. Then its standard deviation is. So in this question they asked about the sum of mean and the variance of a Poisson distribution is 8. Then what is the value of the standard deviation? Means the sum of mean value and the variance value is equal to 8. So based on this we have to find what is the value of the standard deviation we need to figure out. So all these four options, option B, 2 is the correct solution of this question. So let's solve this numerical. So this question belongs to the concept of the Poisson distribution. As I've already told you, if the number of trials are infinite and if the probability of success is very, very small, then I've already told you the binomial distribution is approximated to the Poisson distribution. Whereas if the number of trials is very large and the probability of success is a finite value, then we are going to approximate the binomial distribution into normal distribution. So with these concepts now we are going to solve this question. As I've already told you, in the Poisson distribution, the probability of any random variable is equal to e to the power of minus lambda into lambda to the power of x by x factorial, where x is called as a random variable. Its range is from 0, 1 to up to infinity. So therefore, as I've already told you in the Poisson distribution, which is expectation of the x is equal to variance of x is equal to both are same, means I've already told you the mean value and the variance value are always equal in terms of the Poisson distribution. So mean value is nothing but mean is equal to lambda value, so therefore both should be equal to the lambda value. So therefore in the question they have already given that expectation of x plus variance of x is equal to 8, means in the question they are given the sum of mean value and the variance value is equal to 8. So mean means expectation of x, variance means variance of x is equal to 8. As I've already told you, these both are equal. So let me assume this both value is equal to lambda. So lambda plus lambda is equal to 8. So 2 lambda is equal to 8. So lambda is equal to 4. See, where sigma is called as the standard deviation and sigma square is called as the variance. Sigma is the standard deviation. So square of the standard deviation is called as the variance. So variance is equal to, lambda. So variance is equal to lambda. So variance of x is equal to same thing, lambda written. So variance is nothing but simply it is a square of the standard deviation, which is sigma square is equal to x, lambda. So sigma is equal to under root over lambda, but lambda value we know which is equal to 4. So under root over 4 is equal to 2. So therefore sigma is called as a standard deviation, its value is equal to 2. So sigma, if sigma is called as standard deviation, then sigma square is called as a variance. And let me give you some important facts regarding this standard deviation. See, whenever the sigma value increases, we can say that the data is widely spread. So whenever the sigma value increases, the data is widely spread across the value of the function f of x. If the sigma decreases, means we can say that it is closely packed. The data is very closely packed around the function x is equal to 0. So whenever the sigma increases, whenever the standard deviation increases, the data is very widely spread for all over the range of the x. Whereas whenever the sigma decreases, we can say that the data is very closely packed. It is closely packed around the x is equal to 0. So these are the important points regarding the standard deviation. So finally the solution is equal to standard deviation is equal to 2 is the correct solution of this question. So now we are going to solve the 73rd question. See the question here. If x is a binomial variate with n is equal to 6 and p is equal to 1 by 3, then what is the ratio of probability of x is equal to 2 by probability of x is equal to 4? So this question belongs to the concept of the binomial distribution. If there n is called as the number of trials is equal to 6 and p is called as the probability of success of an event is equal to 1 by 3, then we have to find what is the ratio of the probability of x is equal to 2 by probability of x is equal to 4. So what are the four options? Option A is the correct solution of this question. So let's solve this numerical. So this question belongs to the concept of the binomial distribution. As I already told you, for a binomial distribution is going to apply only when n is equal to finite value and p is equal to finite value. So the formula is probability of x is equal to r is equal to NCR into p to the power of r into 1 minus p to the power of n minus r, where p is called as the probability of success of the event. It is success for r times and remaining n minus r times it is a failure. So 1 minus p is called as a failure of the event which is occurring for n minus r number of times, where n is called as the number of trials and r is called as for this much amount of trials the probability of the success is going to get happen for that event. So NCR into p to the power of r into 1 minus p to the power of n minus r. In the question they are given the number of trials is equal to 6 and the probability of the success of the event is equal to 1 by 3. So what is the failure? Failure is equal to 1 minus p, which is 1 minus 1 by 3 is nothing but 2 by 3. As I have already told you, which is, see, now we have to find what is the ratio of the probability of x is equal to 2 by probability of x is equal to 4. So if you substitute here n is equal to 6 c, whereas now r is equal to 2, so 6c2 into p value which is 1 by 3 and r value is equal to 2 and 1 minus p is 2 by 3 whole to the power of n minus r. N minus r means nothing but 6 minus 2 which is equal to 4. Similarly for x is equal to 4, we are going to get substitute r is equal to 4 in this expression. So n is equal to 6c4, p is nothing but 1 by 3 whole to the power of 4 into here 2 by 3 into 1 to the power of 6 minus 4 which is equal to 2. So therefore as the basic formula which is NCR is equal to NC n minus r. Here n is equal to 6 and r is equal to 2. So 6c2 is equal to 6c, 6 minus 2 is equal to 4. So therefore 6c2 is equal to 6c4. So therefore these two are going to get cancelled. And here 1 by 3 whole square and 1 by 3 whole to the power of 4. So 1 by 3 whole square cancels in the both the numerator and the denominator. So finally we are going to get 1 by 3 whole square in the denominator. Similarly, 2 by 3 whole to the power of 4 by 2 by 3 whole to the power of square means the square part is the common between upper part and the down part, so it is going to get cancelled. So only we are going to get 2 by 3 whole square in the numerator. So 2 by 3 whole square in the numerator, and 3 square both are in the downward direction, so both are going to get cancelled. So only 2 square is going to get remaining, so 2 square is equal to 4. So this is the correct solution of this question. And also I have already told you the mean value or the exponential of the random variable in the binomial distribution is equal to n into p, whereas the variance of the random variable in the binomial distribution is equal to np into 1 minus p. So these are the important points. So final the solution is equal to 4. So see, I have already told you, whenever the n value is very large and the probability of that is success of the event is very small, then the binomial distribution is approximated into Poisson distribution. Whereas if n is very large and the probability of the success of the event is a finite value, then the binomial distribution is going to approximate it into normal distribution. So these are the important points that you always have to remember while solving the probability questions. So now we are going to solve the 74th question. See the question here. A random variable x has x bar is equal to 0 means the mean value or the exponential value is equal to 0, and sigma x square is equal to 1. It means that the variance value is equal to of the random variable x is equal to 1. So form a new random variable y is equal to 2x plus 1. So from the random variable x we got the random variable y with this expression y is equal to x plus 1. Then the values of the y bar means the mean value or the expression value of the y random variable we need to figure out, and sigma y square is nothing but we are going to call it as the variance of the random variable we need to figure out. So basically they are given the for a random variable x they are given the mean value and the variance value they have given, and they are going to form a y random variable from the x by this y is equal to x plus 1. So now we have to find what is the new random variable mean value and the variance value we need to figure out for this random variable y we need to figure out. So the four options, option C 1 and 4 is the correct solution of this question. So let's solve this numerical. So in the question they are given a random variable x. For this random variable x they are given x bar is equal to 0. It means that the mean value or the exponential value of the random variable x is equal to 0. Similarly, they are given the sigma x square is equal to 1, means the variance of the random variable x is equal to 1, where sigma is called as the standard deviation and sigma square is called as the variance. So variance of this random variable x is equal to 1 they have given. So now with the help of this random variable x they are going to form a relation. We are going to get the new random variable y. So y is equal to 2x plus 1. So with the random variable x, with this equation we are going to get the new random variable y. Then we have to find what is the value of the y bar, means the exponential or the mean value of the random variable y we need to figure out, and sigma y square is called as the variance of the random variable y we need to figure out. So these two values we need to figure out. So let me give you some important formulas here. Exponential of ax plus or minus b is equal to a into exponential of x plus or minus b. Similarly, variance of ax plus or minus b is equal to a square into variance of x. So there is no b term. So now with this basic formulas we are going to apply for this relation. So I want to find what is the exponentials of the y. So or the mean value of y is equal to, with y is equal to 2x plus 1. So it is in this format. So same format. So therefore a is equal to 2 and b is equal to 1, and this is only plus 1. So 2 into exponential of x plus 1, but exponential of x is equal to 0, so 2 into 0 plus 1 is equal to 1. So therefore we can say the mean value of the random variable y is equal to 1. Similarly, variance of the random variable y we need to figure out, but y is equal to 2x plus 1. So by applying this formula we are going to get a is equal to 2 and the b is equal to 1, but there is no b term, so therefore only a square. So 2 square into variance of random variable x. So in the question they have already given the variance of the random variable x is equal to 1. So 2 square into 1 is nothing but 4. So therefore simply we can say the variance of the random variable y is equal to 4. So therefore finally we are going to get which is the the mean value of the random variable y is equal to 1 and the variance of the random variable y is equal to 4. So these are the important formulas that you always have to remember. The average or the mean value of ax plus or minus b is equal to a into the mean value of x plus or minus b, because mean is also called as the expectation. So variance of ax plus or minus b is equal to a square into variance of x. So these are the important formulas that you always have to remember in the probability. So now we'll discuss some more important formulas regarding these concepts. So now I will discuss some important formulas regarding the concepts of the random variables, which is suppose x and y are the random variables. X and y are the random variables. So therefore now the expression of ax plus or minus b is equal to a into expression of x plus or minus b. Similarly, the expression of ax plus or minus by is equal to a into expression of x plus or minus b into expression of y. Whereas similarly, the variance of the ax plus or minus b is equal to a square into variance of x. There will be no b term. You can say clearly here. Similarly, variance of ax plus or minus by is equal to a square into variance of x plus b square into variance of y plus or minus. If it is a plus, take here plus. If it is a minus, means take here minus. 2ab into covariance of x comma y, whereas covariance of x comma y is equal to expression of x into y minus expression of x into expression of y. So these are some of the important formulas. Suppose if x and y are the independent random variables. Independent means there is no relation between the y and x. Suppose if you take y is equal to some ax plus b, so we can say y is depending on the random variable x. So we can say x and y are the dependent random variables. Suppose there is no relation between x and y, so we can say x and y are said to be independent random variables. Suppose if they are independent random variables, then we can say simply the covariance of x comma y is equal to 0. If you substitute in this equation, if it is equal to 0, if you take this part to LHS, we are going to get expression of x into y is equal to expression of x into expression of y. So therefore, if x and y are the random independent variables, then simply we can say that the covariance of x comma y is equal to 0 and expression of x into y is equal to expression of x into expression of y. So these are some of the important formulas that you always have to remember while solving the questions of the expectations and the variance values. So now a few more important formulas. Now we are going to discuss expression of x plus b whole square. It is what is the value. So it is like a plus b whole square. A plus b whole square is nothing but a square plus b square plus 2ab. So expression of x square plus 2bx plus b square. As I've already told you, this is now it is going to become expression of x square plus 2b is a constant value, it is going to come outside. So 2b into expression of x plus, so b square is a constant, it is going to come as it is, plus b square. So this is the thing. So now variance of ax plus or minus by plus or minus c is equal to here a square into variance of x plus, always there will be a plus sign, plus b square into variance of y, but c is a constant, there is no random variable, so we are going to neglect it. So this is the formula that you always have to remember. Similarly, expression of x to the power of n is equal to sigma x to the power of n into p of x. This is for the discrete nature. Whereas for the continuous nature, which is integration of x is equal to minus infinity to plus infinity x to the power of n into f of x into dx, where f of x is called as a probability density function. So this is for the continuous nature. So these are the important points that you always have to remember. So now we are going to solve the 75th question. See the question here. A man with n keys wants to open a lock. He tries his keys at random. The expected number of attempts for his success is, keys are replaced after every attempts. So after every attempts they are going to replace the keys. So for the four options, option B, n is the correct solution of this question. So in this question they are saying that suppose a man has n number of keys and he wants to open a door key. So he wants to open a door with a key. So out of this n keys, only one key is the correct one and remaining keys are the wrong one. So therefore simply we can say that here we see in how many number of expected times he can remove the door with the help of this key. So here after every attempt he is going to keep the key in the back itself. So therefore we can say he is replacing each and everything again. So for the four options, option B, n is the correct solution of this question. So let's solve this numerical. So if a person has n number of keys, so out of this only one key. So with the help of only one key, you can open that particular door. So remaining n minus 1 are the failure events. So with the help of one key, he can open the door. So the event is success. And with the help of remaining n minus 1 keys, if he tries to open the door will never open. So we can say it is a failure events. See, after he using one key, and is trying to open the door. Suppose if it is not open, he is keeping back that key in the back. So therefore always he is going to get n keys. So therefore always after trying with the help of that key, he is keeping glass or is replacing again in the n keys. So that is the meaning of replacement. He is using and is keeping it back. So it is called as a replacement. So now we see, you can see clearly only one event is a success out of total number of events. Okay, so therefore the probability of success is equal to favorable by total number of outcomes. So favorable outcomes by total number of outcomes is 1 by n. Similarly, the probability of failure is equal to the total number of unfavorable events by total number of outcomes, which is failure is nothing but n minus 1 by total number of outcomes is n. So therefore the probability of success is equal to 1 by n and the probability of failure is equal to n minus 1 by n. So we can say simply, if there are n keys and if he tries for n times, definitely at least for one time he can open that door. So therefore if he tries n times with that n keys, then we can expect at least one time the lock will be opened. So you can simple guess also. Suppose if you have two keys and if you want to open the door, only one key is correct one. So at least you need two chances to open that door. So therefore we can say simply, if you try n times, then we can expect at least one time the door will be open. So therefore we can say simply, the expected number of events is equal to the expected number of attempts to open the lock or door is nothing but n. So n is the correct solution of this question. So if you have n keys, definitely the expected number of attempts is equal to n times to open the door at least one time. So therefore if you try n times, then we can expect at least one time the lock will be open. So therefore the expected number of attempts is equal to n. So n is the correct solution of this question. So this is the last question of this lecture. See the question here. The Fourier transform of the function f of x is equal to x into e to the power of 4x square. So for this function f of x is equal to x into e to the power of 4x square, we have to find what is the Fourier transform we need to figure out. So out of the four options, not even one option is correct. All options are wrong. So this question is given in the TS Transcript 2018. So if you tick any option, you will get the answer for this question because all options are wrong. So now we'll solve this question and we will try to get the exact solution. So for the function f of x is equal to x into e to the power of 4x square, we have to find what is the value of the Fourier transform. So let me give you small basics here. The Laplace transform of f of t is equal to integration from t is equal to minus infinity to plus infinity f of t into e to the power of minus st into dt. Suppose if you want to find what is the Fourier transform of f of t, just substitute in the place of Laplace transform, replace s by j omega. So if you replace s is equal to j omega in the Laplace transform, the new expression what you are going to get, it is called as a Fourier transform. So in this one, replace s by j omega. So we are going to get integration from minus infinity to plus infinity f of t into e to the power of minus j omega into t into dt. So we can say this is the expression of the Fourier transform. So now this I will write in terms of variable t. So now I can write in terms of variable x also. So replace t by x, we are going to get the Fourier transform of f of x is equal to integration from minus infinity to plus infinity f of x into e to the power of minus j omega x into dx. Where x is called the dummy variable, you can go for any other variable, t, x or any variable. So we can say this is the Fourier transform of f of x, which is equal to integration from minus infinity to plus infinity f of x into e to the power of minus j omega x into dx. So this is the formula. With this formula we are going to solve this question. Suppose if I take a function f of x is equal to e to the power of 4x square, but we have to find the Fourier transform of x into e to the power of 4x square. But first I will find the Fourier transform of this function, and then with the help of some arrangements, we will try to get the value of x into e to the power of 4x square. So I will take the first function f of x is equal to e to the power of 4x square. Then I will try to find what is the Fourier transform of this function. I will figure out. So therefore f of x is equal to e to the power of 4x square is equal to integration of, in place of f of x I have substituted e to the power of 4x square into e to the power of minus j omega x into dx. So now I am going to assume minus omega, I am going to assume it as p. I am going to assume minus omega as p, you can substitute here. We are going to get, just I have replaced minus omega by p, and remaining everything is same. So now I will do the simplification of this expression. So now we are going to do the simplification of this one, which is e to the power of 4x square into e to the power of jpx. So I have already told you e to the power of m into e to the power of n is equal to e to the power of m plus n. So now add the power values, which is 4x square plus j into px into dx here. So here 4x square plus jpx I can write in terms of a plus b whole square like this, which is 2x whole square plus 2 into 2x into pj by 4 plus, see if you see, this is nothing but 4x square plus here 2 2s are 4 cancels, so you are going to get same term, which plus pj by 4 whole square minus pj by 4 whole square. So if this term cancels, still you are going to get the same power. So therefore now this is in terms of a plus b whole square minus this term. So therefore e to the power of 2x plus, here a is 2x and b is pj by 4, so pj by 4 whole square minus of this term, minus of pj by 4 whole square. So now what I am going to do is here e to the power of m, so therefore e to the power of m minus n is equal to e to the power of m into e to the power of minus n. So by this formula, e to the power of this power into e to the power of negative of this power. So same thing I did here. So now what I am going to do, basically you can see clearly this e to the power of minus of pj by 4 whole square, it is independent of x value. So this is a independent of x. So simply we can say it is a constant value. So we can take it outside the integration. So e to the power of minus of pj by 4 whole square into integration of this remaining part we are going to take here. So now what I am going to do, basically, so j square is nothing but minus 1. So j square is equal to minus 1. So minus into minus is plus. So you are going to get here e to the power of p square by 16, because p square by 4 square is 16, because minus and minus 1 into minus 1 is again plus 1. So you are going to get e to the power of p square by 16. Integration of minus infinity to plus infinity. So now in this 2x plus pj by 4, I will take j as common. So if I take j as common, 2x by j plus p by 4. So j is common, 2x by j plus p by 4. If you take j into, same thing we are going to get. See, j into 2x by j plus p by 4 whole square. See, if I take j outside this one, so j square is nothing but minus 1. So minus 1 into, here this is p by 4. 2x by j, so 2x by j is nothing but 2x by j is nothing but into j by j. So you are going to get j square is minus 1, so therefore minus 2xj you are going to get. So minus 2xj whole square into dx. Just I did the j as common and I will take it outside, so you can write in this format. So now I will do the further simplification of this expression. So this is the same expression I have written. So now we are going to simplify this expression. So now I am going to assume p by 4 minus 2jx as some t variable, and now I am going to divide the differentiation with respect to dt. So therefore this is a constant value, so differentiation is equal to 0. So minus 2j into dx is equal to dt. So dx is equal to minus dt by 2j. So this is the value of dx we are going to get here. So now we are going to substitute p by 4 minus 2jx as t and dx as minus dt by 2j in this above expression. We are going to get same thing e to the power of p square by 16 integration from minus infinity to plus infinity, but e to the power of minus of, this is value is t, so t square into dx is equal to minus dt by 2j. So minus 1 by 2j is a constant value. I am taking it outside the integration. So we are going to get finally minus into e to the power of p square by 16 by 2j integration of minus infinity to plus infinity e to the power of minus t square into dt. So now there is a one small basic formula, which is integration of from minus infinity to plus infinity e to the power of minus ax square into dx is equal to under root over pi by a. So you can see clearly here x is equal to t and a is equal to 1. So therefore under root over pi by 1 is nothing but under root over pi. So this value, this integration is going to give you a value which is root pi. So therefore this now is going to become minus e to the power of p square by 16 into root pi by 2j. But I have already told you p is nothing but minus omega. So p is minus omega. So p square is equal to minus omega whole square is equal to, you are going to get omega square. So therefore replace p square by omega square. So we are going to get this expression. Same expression, just I have replaced the p square by omega square. So therefore this is the Fourier transform of the e to the power of 4x square. But we need to find what is the Fourier transform of x into e to the power of 4x square. So now with the help of this one, we are going to try the Fourier transform of x into e to the power of 4x square. So we got the expression of the Fourier transform of e to the power of 4x square is equal to minus e to the power of omega square by 16 into root pi by 2j. See, But we have to find the Fourier transform of x into e to the power of 4x square. So we have to find the Fourier transform of x into e to the power of 4x square we need to figure out. But we know only the value of e to the power of 4x square. But this expression we need to figure out. So here in the Laplace transform for f of t, the Laplace transform is f of s. Suppose if the function is t to the power of n into f of t, its Laplace transform is minus 1 over the power of n into nth derivative of f of s with respect to s, where n is the range from 1 to up to infinity. So therefore now if I substitute n is equal to 1 in this above expression, I am going to get t into f of t giving a Laplace transform which is minus 1 into df of s by ds. So suppose if you want to convert in terms of Fourier transform, just replace s is equal to j omega, that's it. So in the Laplace transform, if you replace s is equal to j omega, we are going to get the corresponding Fourier transform. So here we are going to use the variables as x but not t, so replace t by x. So x into f of x, its Fourier transform is equal to same thing here minus 1, just replace s by j omega. So minus 1 into d of f of j omega by d of j omega. So j is a constant, we can take it outside this one. So minus 1 by j into d of f of j omega by d omega means we have to do whatever the Fourier transform of f of x, just do the differentiation with respect to omega. Then if you multiply by minus 1 by j, you are going to get the result. So minus 1 by j is nothing but, so 1 by j is nothing, minus 1 by j is equal to minus 1 by j into j by j. So j square is minus 1, so minus minus cancels, so you are going to get plus j. So minus 1 by j is equal to plus j. So plus j into d of f of j omega by d omega. So listen carefully. So for x into f of x, the Fourier transform is j into d of f of j omega by d omega means for f of x, the Fourier transform is f of omega or j omega. So we have to do the j into differentiation of Fourier transform of f of omega with respect to d omega. So with respect to d omega we have to do, as I've already told you, the Fourier transform of which is x into e to the power of 4x square we need to figure out. So f of x is nothing but here e to the power of 4x square. For this e to the power of 4x square, the Fourier transform is just now we have did, which is minus e to the power of omega square by 63 into under root over pi by 2j. So we have to do the differentiation with respect to d by d omega for this term into multiply by j. So we have to solve this expression to get the result of the x into e to the power of 4x square Fourier transform. So listen carefully. Suppose if the f of x, the Fourier transform is f of j omega, then for the function x into f of x, its Fourier transform is equal to j into df of j omega by d omega. So this is a formula that you always have to remember. Sir, for f of x, if the Fourier transform is f of j omega, then x into f of x, the Fourier transform is j into df of j omega by d omega. Same thing we are going to do here. So now we are going to solve this expression. So for x into e to the power of 4x square, the Fourier transform is j into d by d omega of this expression. So now we have to do the differentiation of this expression with respect to omega. So minus pi by 2j is a constant, we can take it outside the differentiation. So j into minus root pi by 2j. So now we have to do the differentiation of e to the power of omega square by 16, which is e to the power of omega square by 16. Again do this part, which is 2 into omega by 16. So 2 cancels, jj cancels. So we are going to get finally minus root pi into omega by 16 into e to the power of omega square by 16. So this is the Fourier transform of this expression x into e to the power of 4x square, which is minus root pi into omega by 16 into e to the power of omega square by 16. So this answer is not there in any of the options. So this is the correct solution of this question. So always you have to remember, integration from x is equal to minus infinity to plus infinity, e to the power of minus ax square is equal to under root over pi by a. So this is a very important formula. I will also prove this one. So now I will give the proof of this one, so that if you forgot this formula also, you can easily derive this within a fraction of seconds. Suppose I have already told you integration of x is equal to minus infinity to plus infinity, e to the power of minus ax square is equal to minus e to the power of minus ax square dx is equal to under root over pi by a. So this is the formula that you have to remember. Suppose in case if you forgot, you can easily derive it also, which is assume that a is equal to 1 here. So if you assume a is equal to 1, I am going to derive this expression, which is integration from x is equal to minus infinity plus infinity, e to the power of minus x square into dx is equal to under root over pi. Because I have already told you in the normal distribution, the general formula, which is 1 by under root over 2 pi into sigma x, integration from minus infinity to plus infinity, e to the power of minus of x minus mu x by root 2 into sigma x whole square into dx is equal to 1. So for this expression I am going to assume sigma x is equal to 1 by root 2 and mu x is equal to 0. So if I substitute sigma x is equal to 1 by root 2 and mu x is equal to 0 in this above formula, then we are going to get here 1 by root pi we are going to get, because root 2 and 1 by root 2 cancels, integration from minus infinity e to the power of, this is mu x is equal to 0 and sigma x is equal to 1 by root 2. So root 2 cancels, we are going to get here minus x square dx is equal to 1. So take the root pi to this side, we are going to get integration from minus infinity to plus infinity e to the power of minus x square dx is equal to root pi. So this is a formula that you always have to remember. Either you can go from minus infinity to plus infinity or plus infinity to minus infinity. Still you are going to get the same result, because e to the power of minus x square, e to the power of minus x square, if you substitute x is equal to 0, you are going to get one value. If you take positive value or if you take negative value, it is symmetric with respect to the y-axis. So therefore we can say either you grow from minus infinity to plus infinity or plus infinity to minus infinity, the area under this graph is constant. So therefore you can go from minus infinity to plus infinity or plus infinity to minus infinity. This value is nothing but root pi. So therefore if you keep here minus a, just you have to keep here under root over pi by a. So this is an easy way to remember this one, and I will also give you another method to derive this formula also. So now I will give the another method to solve this proof. So therefore I will give the another method to get the value of this integral. So therefore integration from minus infinity to plus infinity e to the power of minus x square into dx, I have already told you its value is equal to root pi. So now we will solve this one by another method. So this is the function f of x is equal to e to the power of minus x square. It is symmetric with respect to y-axis. So therefore whatever the area here, same area will be here. So we have to find what is the area under this function f of x from minus infinity to plus infinity. So therefore now suppose if I do the square on the both sides, so I square is equal to, you have to multiply this one by another time. So therefore same thing I have written 2 times, because I am doing the square. Square means multiply by 2 times. So therefore here is a dummy variable x, here also dummy variable x. So I am going to replace one of the dummy variable x by y. So I am replacing one of the dummy variable x by y in this term. But in this term I am going to keep it same as this. So therefore I am going to replace one dummy variable x by y in this term. I am going to replace by x by y. We are going to get e to the power of minus y square into, this is dy. So this is dy. So now this is in terms of x, this is in terms of y, both are independent, so we can club it. So therefore integration from y is equal to minus infinity to plus infinity, integration from x is equal to minus infinity to plus infinity, this is from y is equal to minus infinity to plus infinity, this is from x is equal to minus infinity to plus infinity. So therefore you can take everything as a common, e to the power of minus of x square plus y square into dx dy. So you can see clearly this is in terms of the Kardashian coordinate system. So now I will convert the Kardashian coordinate system into cylindrical coordinate system. So therefore in the cylindrical coordinate system, x is equal to rho cos phi, y is equal to rho sin phi, and dx dy is equal to d rho into rho d phi, or simply which is rho into d rho into d phi. So if you want to do x square plus y square, do the x square plus y square, we are going to get rho square common. Rho square into cos square phi plus sin square phi is equal to 1. So rho square into 1 is equal to rho square. So you are going to get rho square. So therefore now I am going to replace all these things in this formula. If you see clearly, x is equal to minus infinity to plus infinity and y is equal to minus infinity to plus infinity means it is a xy plane. Xy plane means simply we are going to get that rho is equal to 0 to rho is equal to infinity and phi is equal to 0 to 2 phi. It is going to give you overall xy plane with the help of the cylindrical coordinate system. So therefore here e to the power of, this is minus rho square dx dy, replace this value which is rho into d rho into d phi. So now we have to go do the simplification of this one and get the value of the I value we need to figure out. So now we are going to simplify this expression. You can see clearly this rho and phi are independent of each other. So I can take this one d phi here, from phi is equal to 0 to 2 pi d phi, like separable we are going to separate because both are independent. So therefore integration of rho is equal to 0 to infinity rho into e to the power of minus rho square into d rho. So now I am going to simplify this expression. So you can see clearly I am going to assume it is minus rho square as mu. So therefore if you do the differentiation with respect to mu, so minus 2 rho into d rho is equal to du. So therefore rho into d rho is equal to minus du by 2. So therefore here See, suppose if rho is equal to 0, then mu is equal to minus 0, which is equal to plus 0. So mu is equal to 0. But if rho is equal to infinity, minus infinity square is minus infinity. So therefore mu is equal to minus infinity. But e to the power of minus rho square is u. So e to the power of u into rho into d rho is minus dq by 2. And here integration of d phi is phi. Substitute the limits. Lower limit is 0 and upper limit is 2 pi. So upper limit minus lower limit, which is 2 pi minus 0 is equal to 2 pi into, here minus of is a constant. We can take it outside the integration. Minus of into integration from u is equal to 0 to minus infinity, e to the power of u into du. So 2 cancels. So pi into minus 1 is minus pi into. So integration of e to the power of u is again e to the power of u. Substitute the limits. 0 to minus infinity is equal to minus pi into upper limit minus lower limit. So e to the power of minus infinity is nothing but 1 by e to the power of infinity, which is equal to 1 by infinity is equal to 0. So you are going to get 0 minus lower limit e to the power of 0 is equal to 1. So minus pi into minus 1 is nothing but plus pi. So therefore I square is equal to plus pi, but I is equal to root pi. So therefore we can say that area under this function f of x is equal to always is equal to root pi. So therefore always you have to remember only one thing, which is area under the function x is equal to minus infinity to plus infinity, e to the power of minus x square is equal to root pi. But if you want to write the for minus ax square, so minus ax square means just replace pi by root a. So therefore pi by a. So we are going to get, this is a formula. So I have already told you by different methods how to remember this formula. Also I have already given by 2 methods how to remember this formula. Suppose if in case you forgot also, you can easily derive this expression. So by this lecture, we have successfully completed the questions in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notice comes on mobile. If any improvements in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Please do watch all our videos in the YouTube itself, so that our channel will grow and it will reach to the more number of students. Thank you so much for watching this lecture. Keep smiling, take care, and bye bye.